research papers for this simple thing. Is that okay for you? Okay then. Water filling algorithm means, let us say, yeah, the cell phone is there. The cell phone is having a battery power of 0.5 watts. So, but at the same time, the cell phone has to send the signal. So, how much power that cell phone can use to the maximum extent for that video transmission or for talking to the base station? Yeah, whatever battery power is there, only that battery power only it can utilize cell phone. Or if you say the cell phone is there, the cell phone is sending a video over the Bluetooth, this cell phone is sending a video over the Bluetooth to the other cell phone, let us say on ISM band. So, again Wi-Fi access point is sending its signal to the laptop. Remember, Wi-Fi also uses ISM band as well as Bluetooth also use the same ISM band. So, from the cell phone, if it is sending a Bluetooth signal to the cell phone will be creating interference to the laptop that is getting Wi-Fi signal. So, we have to control this interference also. Or we have to send the signal from the cell phone to the base station with the existing power only, with the existing battery power only. That's what is water filling problem. Here I am telling you again. So, how much capacity we can bear? How much capacity we can pass the signals? With how much data rate we can send the signals over any channel? That's what I am talking now. Yeah, for example, here this pipe is there. This pipe is very thick. Because it is a thick pipe, through that thick pipe, we can send signals, we can send water with more flow. More amount of water can be sent through this pipe. Whereas here thin pipe is there. Thin pipe is there means through the thin pipe, we can send the water with the lesser flow only. If we send the water with the more flow, what happens to that pipe? It will burst out. So, we can send water according to that thinness of the pipe or thickness of the pipe only. This water sending is nothing but, if you take it as the channel, if that pipe or channel is having a more channel gain, if that pipe or channel is having more channel gain, how much data it can carry? It can carry more data. Whereas thin pipe is there. Thin pipe is there means that thin pipe, it can carry the water with a lesser speed only. Or if you take this thin pipe as a channel having a smaller channel gain. If channel is having a smaller channel gain, what happens? That channel having a smaller channel gain can't carry more amount of data. If we try to send more data, what happens? We will be getting more bit error rate. Or here thin pipes are there means it can't carry the water with more flow. Our pipe will burst out if we are sending the water with more flow. Same thing, here channel is there with a smaller channel gain. So, this channel having a smaller channel gain can carry the data with smaller data rates only. So, again capacity I am talking about. So, C equal to this, you may know equation, Shannon capacity formula. Shannon capacity formula is, yeah, capacity or maximum data rate that can be passed through the channel. C equal to B log 2 1 plus SNR. SNR is nothing but PH by sigma square. Here PI HI by sigma square means here HI is the channel gain or fading, amount of fading it is having or amount of channel gain it is having. Sigma square is the additive white Gaussian noise or noise that is there in the receiver parts. So, here up to this everyone understood. It is normal things only which you already know. So, I have taken one simple problem here. So, here capacity, let us say that xi equal to 1 value, xi equal to 1 value, please do not take xi, please do not take xi. So, sigma pi less than or equal to pt. If you try to explain this equation, that means that we are having m channels here, we are having m channels here, over ith channel we are sending pi amount of power, we are sending pi amount of power. So, pi amount of power means if you take xi equal to 1, so total amount of power that you are sending, total amount of power let us say cell phone over the ith channel, it is sending pi amount of power. How do we decide that pi, you tell me? How do we decide that pi power? Let us say that the channel, instead of water, take it as a power. If channel is able to, channel is having more channel gain, then is it beneficial to allocate more power or is it beneficial to allocate lesser power? If channel is having more gain. So, here if channel is having more gain means, more channel gain means, then the channel is able to bear, channel is able to have more data rates. Channel can have more data rates here. Please see here. This you take it as a channel. Let us say you are traveling, if you are traveling, you can carry 1 kilo, 1 kg luggage. But instead of carrying 1 kg luggage, if you are carrying 1.5 kg luggage, what happens? You will be tired. In the same way, or instead of carrying 1 kg luggage, you are carrying only half kg luggage, then you will be traveling with more comfort. In the same way, here channel having more channel gain can carry more data. Here it is more data rate, more data it can carry. Similarly, channel having smaller channel gain, it is having a small data rate here. It can carry only small data. Because channel having more channel gain can carry more data, how much amount of power we can allocate there? If we allocate more power, obviously, if we allocate more power, please see here. So, capacity is proportional to pi value here. C equal to Ba log 2 1 plus Pi Ha base sigma square. So, capacity is proportional to Pi value, log of Pi or Pi. So, if you are allocating more power, then what happens to the data rate or capacity? Capacity also will be increased. But we increase the capacity, we allocate more power based on channel gain Hi. Anyway, the channel having more channel gain can carry more data. That is why we try to allocate more powers here. We try to allocate more powers here because the channel can carry more data. Whereas channel having lower channel gains, we try to allocate small powers so that bit error rate also will be small at the end, at the receiver. So, that is what is water filling algorithm. So, here we are allocating, so over the mth channel, so here I equal to 1 to m channels are there. So, over all the channels, over all the m channels, how much power we can allocate here for all the channels, for all the m channels? Remember, this battery is having 0.5 watts only. How much amount of power we can allocate for the data transmission from cell phone to the base station? Only 0.5 watts. That means P1 plus P2 etc. up to Pm. can be less than or equal to Pt. Here Pa is the power allocated over the ith channel. So over all m channels we are allocating P1 plus P2 plus etc. up to Pm. The total combination of powers should be less than or equal to Pt. Here Pt is the total amount of power that battery is having. So that is regarding second equation. First equation you know. This Wa can be taken as bandwidth or bandwidth for the ith channel or something you can take. Here Xi can be interference related to this. How it is related to the interference means I have already told you. So here power allocated. So it is creating interference of, let us say, so Vi Pi interference is created to the laptop. Once the cell phone is sending Pa amount of power to another cell phone over the Bluetooth, but because of same channel usage, the cell phone is creating interference of Vi Pi. Vi or Xi? Okay, Xi Pi. Xi Pi amount of interference is created to the laptop there. So that Xi can be taken as channel gain over the interference. Channel gain of the interfering term. Everyone understood these equations? So with the available power, we have to maximize the capacity that is sent to the receiver, and at the same time powers are to be more than 0. Is there any doubt in these expressions? This is the generalized water filling. I mean now I am going to solve this water filling problem. How to solve the water filling problem means, how to solve the water filling problem means, let us say here they take the, for such type of constrained optimization problems, what they try to do is, they try to take, here we have to maximize capacity with respect to sigma equal to 1 to m Xi Pi less than or equal to Pt. Again Pi greater than or equal to 0. So for solving them, they try to take it as, so some Lagrange multipliers. For those who don't know, I am explaining now. They take Lagrange multipliers here, Lagrange multipliers equation. Whatever equation you are trying to maximize or minimize, they try to take that, and some lambda parameter or something they take, some parameter. I will explain the significance of that lambda value. Lambda multiplying with sigma Xi Pi minus Pt. Meaning that, let us say that you want to optimize the performance. Optimizing the performance means, for example, when you go for tea, if they are offering biscuits, you will feel little bit happy. But instead of offering instead of offering biscuits, if they are offering you samosa or something, you will feel more happy. So how much proportionately you are trying to decrease this value? How much proportionately the left hand side term is close to the right hand side term? That proportionate term is decided by this lambda value here. So how they try to do is, they try to differentiate with respect to 0. Why they try to differentiate means, they want to find out, for example, we want to maximize something or we want to minimize something. So how do we do this? By doing differentiation, we try to find out the maximized value or minimized value. So, by doing some sort of like this, by doing differentiation, we try to find the maximum value for the data capacity, or we try to minimize the interference there. So, by doing this, you will be getting the equation as, yeah, if you don't understand, please ask me. You will be getting the equation as something like this. By doing differentiation over the powers there, over that parameter there, we will be finding out, you will be getting this equation. So, this is nothing but Wi xi lambda minus Ni. What is the meaning of this means? Yeah, Pi plus means maximum of Pi comma 0. Maximum of Pi comma 0 meaning that, this is the meaning that Pi should be greater than or equal to 0. You tally, if Pi is a positive value, maximum of positive value comma 0, that Pi value will be coming. Yeah, if Pi is a negative value, if at all in the calculations, if you are getting negative powers, so maximum of negative power comma 0, that means power will be 0. That's why this is the Pi greater than or equal to 0 meaning that maximum of Pi comma 0. So, this can be written as, yeah, 1 by lambda minus some Ni bar, minus some Ni bar. Yeah, same thing, same thing. Now, how much power we have to allocate? You tell me, how much power we have to allocate means, what I have done is, if at all noise is increasing, then I have to allocate with smaller power. Why I want to allocate a smaller power means, because anyway noise is more. Remember the channel having very small capacity. Channel having very small capacity can carry only smaller data, because we don't want to have more errors. That's why we try to allocate smaller powers when the channel is having more noise or lesser channel gain. So, same thing, if noise is small, we try to allocate more powers here, because the channel can carry more data. More data means we can allocate more powers. So, this is the basic water filling problem. Now, I will try to explain to you what is the water filling problem, how I have solved that water filling problem. So, I have taken one glass there. Yeah, take it as one glass. In that glass, let us say that, yeah, this is N1 bar level, N2 bar level, N3 bar levels. Let us say that, yeah, that person, that pot making person or glass making person have designed the glass in such a way that the bottom of the glass is at different levels. Here glass is at N1 bar level, this is 0 on y-axis. Glass bottom is there at N1 bar level in this place, glass bottom is there at N2 bar place in this second place. Yeah, here glass bottom is there at N3 bar in the third place. So, let us say that now you want to fill the water. How much water you can fill? How much water you can fill means, let us say that this is the total amount of water that can be filled above the noise levels is Pt. Total amount of water that can be filled in this glass. Let us say this is the water that is there. Total amount of water that can be filled into that glass is Pt, and the height of that water level is, we take it as 1 by lambda. Now tell me, how much is this? How much is this? This is 1 by lambda. 1 by lambda is the height of water level, height of top water level from the ground, from 0 level. So this is 1 by lambda. So above noise level, remember it is the bottom surface of the glass. It is the bottom surface, N1 bar is the bottom surface of the glass. So how much amount of power or water can be filled above that bottom level? Tell me. This is 1 by lambda is the height of the water level from the ground, and Ni bar is the noise level or bottom part of the glass. Ni bar is the bottom part of the glass at the height, what to say, height width or something. Yeah, Pi is equal to 1 by lambda minus Ni bar. So this is nothing but P1 here. This is nothing but P1 here from that equation. This is nothing but P2 here. This is nothing but P3 here. Please see this. More is the noise level. More is the noise level. Yeah, lesser power, because we are taking precautions such that only smaller number of bits gets errors. So here P1 is the power allocated for the first channel, P2 is the power allocated over the second channel, P3 is the power allocated for the third channel. Now what I have done is, instead of doing the powers like this, so what previous persons done is, they try to initialize it to some value, some random value. For this random value, they try to check Pi equal to 1 by lambda minus Ni bar. For all I, they try to calculate powers and they try to check if Pi is less than or equal to Pt, or if Pi greater than or equal to greater than Pt, or if any power is going less than 0, or if any power is going above 0. What they try to do is, if it satisfies this and this, yeah, everything is fine. If it satisfies the required constraints, sigma Pi less than Pt, yeah, required constraint, if it is satisfying, okay. If it is a Pi greater than 0, if it is satisfying, then also it is fine. Then also it is fine. But if at all, for the calculated lambda, if it is more than Pt or some Pi value is going smaller than 0, then what they try to do is, in this case, they try to increase it to previous lambda yeah, plus some delta value. Delta value also they try to take accordingly. Some known delta value. Some, yeah, taken delta value. Yeah, again, they try to calculate Pi equal to 1 by lambda minus Ni bar and they try to take, yeah, if Pi less than or equal to, if it is greater than Pt, or some Pi is going less than 0. They try to check the taken constraints. If the constraints are satisfied, yeah, they will leave the loop. They will loop the for loop or while loop. If the constraints are not satisfying, again, they try to increase the previous lambda with, they try to add the previous lambda with, yeah, some defined delta value, and again they try to keep. Like that, they keep on doing the iterations until all the constraints are met. They keep on doing the iterations until all the constraints are met. What was the drawback here? What was the drawback here? We started with some random value. If that random value turned out to be fine, yeah, within 2 or 3 iterations or within 50 iterations, everything goes well. if that taken initialized lambda value, if something bad happened, our guess is wrong. Our guess is wrong initially, then it means it keeps on iterating, it goes on around the loop, yeah, so many multiple times, thousands or lakhs or crores. So that is the problem. If it is going on taking more number of iterations, what is the problem here? If it takes more number of iterations, yeah, let me tell you. So let us say that base station is given with, yeah, let us say that the cell phone has to send the signal from 0 to t1 time. The cell phone has to send the signal from t1 to 2t1 time. Let us say that in TDM, cell phones are communicating with base station. In TDMA mode, cell phones are communicating with base station. So what happens? What happens this? First of all, every cell phone have to determine how much powers to be allocated. In every cell phone, DSP algorithm will be running before sending the data. The DSP algorithm means solving this optimization problem. So that optimization problem means, so let us say that cell phone has to interact with the base station over this 0 to t1 time only. Second cell phone will be interacting with the base station over this t1 to 2t1 time only. In that case, let us say that, yeah, let us say that 0 to t1 minus delta time, it is allocating, it is doing power allocation only, it is solving PI values only. So how much time is left for sending the data from the cell phone to the base station now? Only delta time is left for sending the data, from the cell phone to the base station. This is, I am telling as an example only. Yeah, here another way is there, if you think of it. So here what I am saying is, first of all, cell phone does the power allocation before transmitting the data. After doing the power allocation or after doing the channel allocation only, cell phone will be communicating its data to the base station. If it is taking more amount of time to do the power allocation or to solve the DSP algorithm, then in that case, very small time will be left for sending the data to the base station. So within that small amount of time, cell phone won't be able to communicate more data. That's why what they try to do is, they try to allocate powers as soon as possible. If we want to allocate the powers as soon as possible, then what is the method? What is the method? We have to reduce number of iterations, or we have to use closed form solutions. Closed form solutions there. So here we try to find closed form solutions. Closed form solution means, let us say that sigma pi less than or equal to pt. Again I am repeating, our problem here is, in this water filling algorithm, the main problem is, if lambda is not taken properly, then it leads to more number of iterations. If it is leading to more number of iterations, yeah, comparatively data transmission will be taking very small amount of time. Yeah, within that small amount of time, it won't be able to communicate the data to the receiver. More data. That's why we try to find closed form solutions here. Closed form solutions means, for example, constraint here is sorry, sigma pi less than or equal to pt. So what is the optimum power? In which way we will get the optimum power? Tell me. Yeah, let us say 1 plus 2 is less than or equal to 6. 1 plus 2 is less than or equal to 6, or 2 plus 3 is less than or equal to 6. or yeah, another way, 1 plus 5 less than or equal to 6, or 3 plus 2 plus 4, 2 plus 4 less than or equal to 6, which one will be giving more power allocation? Remember, we have to allocate capacity or data rate is proportional to the power allocated. If we want to maximize the data rate, we have to maximize PI value. Out of these combinations, which one is the most suitable combination here? 2 plus 4, more powers. 2 plus 4 equal to 6. Yeah, that's why instead of taking this, they try to take it as equal to PT. This is the best way to optimize the capacity or to maximize the data rate. So, sigma Pi equal to PT means, so Pi equal to already found out 1 by lambda minus Ni bar. Yeah, okay. Yeah, okay. This one is the one. Yeah, I forgot to mention W. Okay, anyway, similar equation. W multiplying with 1 by lambda minus Ni bar. This is the PA equation with 1 by lambda. Here lambda is unknown value. Lambda is unknown value, or up to how much height we have to pour the water into the glass. That we don't know. Ni bars are known values, W's are known values. 1 by lambda only is the unknown value here. That means up to how much height we have to pour the water into the glass. So, this one we have to find out 1 by lambda. So, here Wi multiplying with. So, what we have taken, sigma Pi equal to sorry, T vachinda. Okay. Yeah, within 15 minutes, please come back. Tea చల్లబడుద్ది సార్. I mean, అసలే మీరు ఫీల్ అవుతున్నారు నేనేం పెట్టట్లేదని. To take equal to sign, sigma Pi equal to PT. Yeah, again Pi equal to Wi multiplying with 1 by lambda minus Ni bar. Here 1 by lambda is the unknown value, or up to how much height we have to drop the water, we have to pour the water inside the glass. So, if you substitute sigma I Pi equal to PT, sigma I Pi equal to PT, so sigma I, Pi is nothing but equation is there, that equation we have taken. So, 1 by lambda equal to PT plus sigma I equal to I value Ni bar by, I mean some equation in terms of PTs and Ni bar. Yeah, actually we are using, we are having some m number of channels. Out of m number of channels, we are using only k number of channels. Why? Please tell me. We are having totally m number of channels. M number of channels. Yeah, here. But we are trying to use k number of channels only. Why? Yeah, let us say I.
All channels may be not used at a time.
No, sir. No, sir. Yeah, I told you traveling example. If I can carry 1 kilo luggage, if I carry 0.5 kilo, half kilo luggage, then I will be fine. Yeah, but instead of carrying 1 kilo luggage, I am carrying 100 kilos. 100 kilos. Yeah, while doing gym also, instead of lifting the weight of 1 kg, you have lifted the weight of 100 kgs. So what happens? You will be collapsed down. So same thing happens here. Here, if noise level is there, yeah, let us say, noise level is so high for the second channel, so but you have poured the water up to this height only. Up to this height only. So this is the P1 part, power allocated for the first channel. This is the power allocated for the third channel. P1 and P3 are the power allocated. P2 is? Huh? Yeah, because noise is more, noise is more, we can't allocate any power there. Yeah, you are trying to lift 100 kgs weight for the second channel. That's why here P2 is 0. We don't allocate any power for the second channel because it is not able to carry any more data. Even single bit of data also it is not able to carry. That's why we don't allocate any power here for the second channel. Yeah, similarly here, that's why instead of taking all M channels, we are taking only K channels only here. K channels only. So what we have done is, here noise levels, we are arranging noise levels in ascending order. Once noise levels are in ascending order, powers will be in descending order. Yeah, if noise levels are increasing, powers will be in decreasing order. That means that here, this is a P1 value, this is a P2 value, this is a P3 value. So here, N1 bar less than N2 bar, less than N3 bar. Once I am arranging the noise levels or channels in the ascending order noise values, then in that case, P1 will be more than P2 and P2 will be more than P3. So once noises or channel gains are arranged in ascending order, powers will be coming in descending order. That's what we have done. This is the original channel model, but the channel model we have converted it into the ascending order noise levels. So that P1 more than P2 more than P3. Something like this. So here what happens? Yeah, what happens here? PM will be 0. Here PM is last. I have told you out of M channels, we are using only K channels. So K plus 1th channel will be having 0 value. Please see, P3 is more than 0. P4 or Pk plus 1, Pk plus 2, Pm values will be zeros there. So last powers will be zeros. So here the thing I have to find here is K value. That K value I try to find. That K value how to find? So now I have found out lambda value initial. I will be finding out lambda values by finding K value first. This K value we are trying to find out now. So, but what happened here? So, PA is more than or equal to 0. This is another constraint we have. So, PA is nothing but Wi 1 by lambda minus Ni bar greater than or equal to 0. Wi 1 by lambda is nothing but PT plus sigma I equal to 1 to K or something Ni bar divided by lambda. Let us take it as some J value. J equal to 1 to J bar minus Ni bar greater than or equal to 0. If you substitute after that, let us say that PT, sigma Ni bar, this is K value. Sigma J equal to 1 to K, Nj bar minus K Ni bar greater than or equal to 0. Something like this equation will be coming. From these equations, how I try to do it now is, don't worry, I will show the MATLAB code after this. So how this equation I got, first I will go for K equal to 1. That means that I pour the water up to this level only. I pour the water up to this level. That means here K equal to 1. I am starting with K equal to 1. Up to this level only I am tallying. After that I am checking this equation for K equal to 1. For K equal to 1. Still that is less than. That means that still it is greater than or equal to 0. This equation I will be checking. Again I will be going for K equal to 2. Here K equal to 2 means, for the two channels we are allocating powers. For the two channels we are allocating powers. We will be checking this constraint. We will keep on increasing the K equal to 1, K equal to 2, K equal to 3, like that. How many channels, for how many channels, that same constraint will be satisfied. That same equation will be satisfied. Like that, I keep on increasing the K value until it is no longer satisfied. Until that equation is no longer satisfied. So how many number of iterations will be coming? Maximum. How many number of iterations will be coming? First I am starting with K equal to 1. First I am starting with K equal to 1. Okay, this is good. This equation is satisfied. Again I am going to K equal to 2. K equal to 2. Maximum K value that satisfies that equation will be maximum K value. We are pouring the water here. Okay. Still sigma PA is less than PT. Let us say we have increased the K level to 3. Once we have increased the K level to 3, sigma PA less than or equal to PT only is there. So if we increase up to, let us say that we have poured the water up to this over the 4 channels. Over the 4 channels. Now here still sigma PA is less than or equal to PT. So obviously we will try to increase the K value until sigma PA becomes equal to PT. Until sigma PA becomes equal to PT. Remember, our main constraint is, up to, we have to get up to, total power should be equal to PT value. Should be equal to PT value, not less than. So maximum, for how many channels we can, over how many channels we can allocate the power, or over how many noise levels we can allocate the water, we can pour the water here. Over how many channels we can pour the water here. Remember, we have taken M channels. M channels. So K equal to 1 first iteration, K equal to 2 second iteration, maximum iteration that it can go is up to M levels. So only M iterations only, maximum it will be coming. So instead of going for 1000 iterations or 1 lakh iterations, going for M iterations is always okay. That's what I have done. Now I will show you the MATLAB code. Here NS, number of channels are taken as 64. Let me do this. Okay. Number of channels are taken as 64. NS equal to 64. I have used this code for cognitive radio. That's why I have taken it as a secondary user. NS means secondary user, number of channels. So variance, sigma square. Sigma square, noise variance is taken as, these are rough estimates only. Later, PT, total amount of power. Total amount of power. Total amount of power is taken as, less than 1 milliwatt or something. Around 1 milliwatt. Yesterday I have asked, this is how we have to, this H is taken as, in the comments it is there. In H is taken as Rayleigh fading. What is the meaning of Rayleigh fading? Rayleigh fading, you know right how Rayleigh fading comes. We have to take the Gaussian distribution here. Rayleigh fading is nothing but Gaussian plus J, another Gaussian. Why it is Gaussian? Real part is Gaussian and imaginary part is Gaussian. Tell me. Huh? Yes, Gaussian distribution. Because please see, what is when Rayleigh fading comes? When there is non-line of sight. When there is non-line of sight from the transmitter to the receiver, so many obstructions are there, lakhs or crores of obstructions are there. In this path, signal is going. In this path, signal is going. In this path, signal is going. In this path, signal is going to the receiver. So here, each path is taken, each path is taken, each path is taken, each path is taken. If 1 lakh paths are there, if 1 lakh paths are there, combination of 1 lakh paths will give Gaussian. Remember, yeah, in the grade sheets also, you must be doing the grade sheets, right? How will be the grade curve of your class? Obviously, it should follow Gaussian curve. If you don't follow the Gaussian curve, means that committee members will reject your grades, saying that something is wrong with your grades. Meaning that, what is the meaning of Gaussian? Some average value is there, some average value is there, whether the student is passing above the average value or below the average value. That is nothing but Gaussian. Similarly here, when 1 lakh or more than 1 lakh number of signals are coming towards the receiver, combination of more number of signals will be producing Gaussian distribution. Yeah, that's why it is real part is Gaussian, imaginary part is Gaussian here. Yeah, this is what is Rayleigh fading. Rayleigh fading comes in the non-line of sight communication, or no line of sight is there between the transmitter and receiver. That means receiver is not able to see the transmitter directly, or transmitter is not able to see the receiver directly. When non-line of sight is there, then it is Rayleigh fading. If line of sight is there, then it is Rayleigh fading. So because of more number of obstructions in between, we will be getting Gaussian curve for the real part, we will be getting Gaussian curve in the imaginary part. So how to calculate the amplitude here? How to calculate the amplitude here? Yeah, let us say C equal to A plus JB. What is the amplitude of C? Yeah, C equal to root of A square plus B square. That means that the amplitude of a Rayleigh channel, will be root of Gaussian square plus another Gaussian square. Yeah, that's what I try to take it here. Yeah, please see this. That Randon produces, yeah, Randon means Gaussian distribution, normal. N means normal distribution. So Randon produces normal distribution. Here number of channels taken are NS. So Gaussian distribution or normal distribution for NS channels. Again, square root of minus 1 means imaginary part. Square root of minus 1 means JRI. Again, another normal distribution is taken after the imaginary part. After square root of minus 1, Randon is taken, that is another Gaussian. So Gaussian plus J multiplying with another Gaussian. So how will you produce the Gaussian channel, Rayleigh channel here? Please see this. It is a square root of, H is nothing but, channel gains is nothing but square root of real part of H square, Gaussian square, plus imaginary part of H square. So this is nothing but root of Gaussian square plus another Gaussian square. This is the H is nothing but here is the Rayleigh fading channel. This is how we produce Rayleigh fading channel. Yeah, but here, yeah, don't ask me why I have taken this, because I am producing a better result in this way. Here for exponential distribution, here channel gains I have taken it as exponential distribution. That is another matter. Simply for proving that my results are better than other results, I have taken exponential distribution. Yeah, similarly Debye values also. Similarly Debye values also. Here please see this. Wi values also have taken some random values. Xi values also have taken some random values. Yeah, here Debye values also have taken some random values. Here please don't worry about this. Yeah, I will go to my thing. Should I tell this? So this is iterations, it takes a long time. Okay. Yeah, they are initially taking k equal to ns values. Ns means the total number of channels that are taken. K equal to ns values. Here I am going, here I have explained from bottom to top, k equal to 1 to k equal to 1 to k equal to m values I have taken on the board. Here I am in the MATLAB code, I am going down. K equal to m value I am taking first. K equal to m value I am taking. Here please see this, k equal to 64, 64 channels I have taken. K equal to 64 I have taken 1 by omega, 1 by omega means 1 by lambda, 1 by lambda on the board. 1 by lambda on the board is nothing but Pt plus sum of V and NIO. V and NIO is nothing but, yeah, don't worry about this. This is Ni bar. This is Ni bar. Please check 1 by lambda equal to Pt plus sigma Ni bar divided by, yeah, some value. Here I have written it as, yeah, let me write it properly. Sigma Debye. Yeah, Pt plus sum of Ni bar, sum means here sigma, divided by, here it is nothing but sum of Debye's in the denominator, sum of Debye's in the denominator. After that what we are doing is, for the calculated 1 by omega values, now what I am doing is, I am sorting Ni bars here. I am sorting Ni bar. Sorting is nothing but it arranges Ni bars in ascending order. Remember, we are arranging the noises in ascending order. So in ascending order we are arranging it. Once sorting is done in the ascending order, what we have to do is, once we have arranged the Ni bars in ascending order, then we are trying to find out the indices. What we are doing is, yeah, let us say that Ni bars are equal to 152 is there. So here what I am doing is, Ni bar sorted orders, they are taking it as 1 to 5. In which index you have sorted? In which index you have sorted? So, index order of sorting is, first one is taken as it is, third one is taken into the second. So, third one is taken into the second one, second one is taken into the third. So, this is the index order. Index for arranging the noises in the ascending order. So, once we have arranged the noises in the ascending order, we have to sort doubles also in the same order, right? So, here this is nothing but please see this. After sorting this, everything is coming in ascending order noises. First one is 10 to the power of minus 5, second one is 10 to the power of minus 4, third one also 10 to the power of minus 4. Later 10 to the power of minus 3. That means noises are arranged in ascending order here. After that, here we are trying to find it in, here we are trying to arrange it in here. What happened? This index is nothing but sorted order 132. 132 is the index values. So, into that index values, let us say that WIs are there. So, for the channel, channel 1, W1 is some one value. For channel 2, W2 is some 5, let us say 10. For channel 3, W3 is 4. Here we have arranged the noises in ascending order. Here the channel WI values also we have to arrange in the same order, right? We have to arrange in the same order, na? That's why everything related to the channel, every other parameter related to the channel are arranged in the same ascending order, same index order. So, this is the index is nothing but how we have done the ascending order. So, into the same ascending order, we are arranging this. This Ni0 values are WI values. WI values are there. WI values we are taking in the indexed order only, in the indexed order. You are understanding what I am saying? Everything related to the specific channel, we are arranging in the same order. Next thing. We are going into this one. We are, next thing we are checking. Please see this diagram. Please see this diagram. Let us say that WI Ni bar minus WI2 Ni bar 1. So, I am checking WI Ni bar I means here I equal to 1, right? Let us say 2. 2 means WI2. This is W1, WI2. This is W3. Let us say that up to this level water is poured. Up to this level water is poured means this P1, P2 part. This entire area, that case, W1 is to I Ni bar, Ni bar I. W1 N1 bar. Yeah, if we take I equal to 2, yeah, W1, W2, W1 plus W2, W1 plus W2, N2 bar minus W individual one, W1 N1 bar, W1 N1 bar plus W2 N2 bar. What it indicates? Tell me. Which area it indicates? Left hand side area, how much? Right hand side area, how much? Please remember, each channel width is taken in terms of W's, height is taken in terms of 1 by lambdas. So here W1 and 2 bar, W1 and 2 bar. This is W1 and 2 bar. This is W1 and 2 bar. This area is nothing but W1 and 2 bar. Please see this. This is W1. N2 bar is up to this one. N2 bar is up to this height. This is W1 and 2 bar. W2 and 2 bar. W2 and 2 bar means this is W2 and 2 bar. This is nothing but the left hand side area. Left hand side shown area. If it is, yeah, again, right hand side shown area. W1 N1 bar, W2 N2 bar. This is nothing but W1 N1 bar. This is nothing but W2 N2 bar. Please try to see how much area, after subtracting this area from this area, which one will be left out? Please tell me. Which one will be left out? This is nothing but this part. That part. Everyone understood, right? We are checking now whether it is equal to PT or not. Whether it is equal to the total power or not. Yeah, please see this. For all the K values, I am checking. Yeah, time is getting over. I have to finish this. What happened? Okay, please see this. What is the meaning of this? Please tell me. What UIO means 1. EIO means 1. Pi t of 1, if it is less than PT, and PT is less than pi t of 2. What is the meaning of this? What is the meaning of this? Can anyone please tell me? I mean, am I making myself understandable to you? Am I making myself understandable to you? This area, this subtracted area is nothing but this PT. Whether if it is less than PT, what is the next step we have to do? Again, we have to increase it to third one, W2 plus W3, yeah, plus W3 N3 bar. We have to do this. So we have to increase the K value. Yeah, for how many number of channels we are pouring water? Yeah, that's what. If it is greater than PT, let us say that, yeah, here, yeah, up to this we have filled the water. Yeah, filled water is more than PT. filled water is more than PT. So what we have to do? Let us say that for n channels, yeah, we have poured water up to this. We have poured water up to this. It is less than PT. Yeah, if it is, we have poured water up to this. It is more than PT. For two channels, power allocated is coming more than PT. For one channel, power allocated is coming less than PT. So how many number of channels we have to take? How many number of channels we have to take? One channel only, right? Yeah, same thing they have taken. Here they are trying to calculate that K value for how many number of channels we can allocate the powers, so that remaining channels will be allocated with 0 power. Yeah, that's what they are checking. Whether it is less than PT or more than PT, yeah, based on that, they are calculating K value. They are calculating number of channels, for how many number of channels we have to allocate powers. Once K is calculated, then obviously next step is PI values calculation. 1 by lambda calculation. What is 1 by lambda equation? Once K is calculated, sixth equation can be applied directly. Once K is known value, then 1 by lambda we can calculate. Once 1 by lambda we can calculate PI values in the fourth equation. So we are directly calculating with a smaller number of iterations, we are directly calculating the powers. Everyone understood? Are there any doubts here? With lesser number of iterations, we are trying to calculate the powers. That means for solving this water filling problem, we are taking smaller time. Yeah, next one. Yeah, let us say that now in water filling problem, we are having single constraint only, but here I have taken two constraints. Yeah, fourth equation is one constraint, fifth equation is another constraint. So how to solve this? Can you tell me? Any idea? I told you number of iterations we have to reduce. If we have to reduce the number of iterations, we try to go for closed form solutions as many as possible. So it is like this. Yeah, just a LKG problem. Here two constraints are there. Maybe it is related to the power constraint, maybe it is related to the interference constraint. If two constraints are there, how to solve this means, yeah, let us say 2x plus 3y less than or equal to 6. Yeah, let us say what is that? Yeah, 1, 2, 3, 4. Yeah, 4x plus y less than or equal to, yeah, some 10. What are xy values here? How to solve for xy values? Remember, we have to optimize the capacity. At the same time, we have to follow these 4 and 5 equations. While allocating powers, we have to follow this 4th equation and 5th equation. Again, 6th equation also. But at the same time, solved powers or allocated powers should maximize the capacity. Top one, how to maximize the capacity? How to maximize the capacity here? Yeah, okay, you have your own method, but I am going for my own method, how I have solved this. So equal to 6 I have taken, 4x plus y. Can you tell me what is the drawback of my solution? What is the drawback of my solution? I have taken simply equal to. But everything works fine if I take equal to. No, it can't be applied simultaneously. I mean, some problems will be coming. Always equal to, yeah, yesterday one madam asked, yeah, frequency selective fading, right? Yeah, I think it was madam. Here I have taken the channels are constant values. But once, by the time I do the resource allocation, what happens? Channel may change. Once coherent time is over, channel may change. Yeah, then I will be facing the trouble. Because I have solved this for only fixed channels. So I have taken this equal to here. So once I have taken equal to here, then x and y I can calculate for optimal capacity, for optimal data rate. Once I solve these equations by taking equal to x and y values, we can solve easily. Yeah, in that way, I mean, by using some, I try to bring closed form solutions. Everyone knows what is the meaning of closed form solution, right? I try to calculate the powers by using some equations. Directly by solving something, directly, I try to allocate the powers without going for iterations. Yeah, here please see this. 8th and 9th equation. I try to go for equal to's there. I try to go for equal to's and I try to solve. Again, please don't think that even solution for equal to also it is easy. No. Here it is L are there. L additions are there. L additions means, please see, 2x plus 3y plus 4z something. Yeah, okay, what to say? Equal to, yeah, 6 value. Yeah, here 4x plus y plus something plus equal to 10. No. Is it easy to solve this? Again, you have to go for pseudo inverse or something. Pseudo inverse or something. It is not inversely solvable because 2, 3, 4, 1, yeah, something. This is multiplying with x, y, z equal to 6, 10. We can't calculate inverse directly. We have to go for some other methods. Yeah, I have to take care of this. That's why by thinking logically, I mean, by thinking something, I have come up with some solutions. Yeah, another problem is there. Another problem. For this, I want to inform you about heterogeneous networks. Heterogeneous networks. In heterogeneous networks means, please see the figure. Sorry, please see the figure. In heterogeneous networks means what is 5G or 6G? Main aim is to have seamless communication. What is the meaning of seamless communication? For example, yeah, until you are there in the border of NIT Warangal, you are using Wi-Fi of NIT Warangal. Yeah, let us say that you are moving on the bike, or yeah, don't say bike, you are moving in the car. Yeah, as long as you move inside the NIT Warangal, you can watch the video in your cell phone by using Wi-Fi of NIT Warangal. But once you cross the NIT Warangal, once your car crosses the NIT Warangal, what happens? Wi-Fi of NIT Warangal won't work once you cross NIT Warangal. So what you have to do is, you have to connect with the 3G base station or 4G base station there. Because signal, more power will be coming from 3G base station or 4G base station. Yeah, in that case, what you have to do, but you should not stop watching the video. Even though you have crossed NIT Warangal, you should continuously see the video, watch the video in your cell phone while moving in the car only. Remember. So here, Yeah, that is increasing the coverage area. One of the main aims of 6G or 5G is to improve the coverage area as much as possible by connecting multiple networks. Yeah, this first one is Wi-Fi access. This first one is, let us say, Wi-Fi of NIT Warangal, Wi-Fi network of NIT Warangal. The second one is 3G base station or 4G base station. Now I am moving in my car from Wi-Fi network of NIT Warangal to 3G base station, towards 3G base station. Then in that case, this NIT Warangal Wi-Fi network has to talk with the 3G base station so that my call or my video streaming will be handed over to 3G base station from the Wi-Fi network. Remember, I have to continuously see the videos in my cell phone. Even though I have gone to other wireless network, I have to get the video continuously in my cell phone. To get the video continuously in the cell phone, we have to do the handoff, right? Handoff. Remember, it is one wireless network, it is another wireless network. So doing handoff between two different wireless networks, is it easy or difficult? Is it easy or difficult? Remember, even for doing the handoff in between the same wireless networks base stations, it takes some milliseconds time. Yeah, for doing the handoff between one wireless network and the different wireless networks, obviously it takes more time, because I don't understand the language of you. Because I don't understand the language of you, yeah, it takes time for you to accommodate myself, to accommodate another user. Yeah, or it takes some time for my network to understand you, to understand your network. Yeah, something like that. Doing handoff between two different networks will be taking a long time. But do you want the handoff to be done, handoff to be taking more time? If handoff takes more time, what happens? Yeah, video will be cut off. Video streaming will be cut off in your cell phone. So that's why I will try to do the handoff within very possible time. And again, once it has gone to the other network region, after handoff is over, how much time resource allocation should be taking? Already handoff has taken some time. Handoff has taken some time. If for power allocation or for channel allocation also, if other network is taking more time, what happens? Already handoff time is over. For understanding between, for getting understanding between both of us, it is taking more time. Once I entered into your region, once I entered into your home, you have to do the facilities immediately to me. Yeah, otherwise, I'll be worried, I'll be scolding you. You are understanding, right? That's why here, as soon as it enters into some other network, the cell phone should be allocated with channels, the cell phone should be allocated with powers within very, very, very minute amount of time. So here also, resource allocation should be taking very small amount of time. So that's what. Here. Yeah, please read this. I'm tired. I will sit by the time you read. You know about femtocells and macrocells, no? So if we are allocating channel means, yeah, obviously that channel allocation will be creating interference to all the users. In LTE, if we are allocating channel, yeah, some F1 channel means that F1 channel allocation to me, to my cell phone will create, let us say that some smaller cells are there. Some smaller cells are there. So it will be creating interference to this small cell. This will be creating interference to, yeah, some other femtocell. So if I am allocating some channel, F1 channel to the user, because of this F1 channel allocation to the newly coming user, this will be creating interference to the femtocells. Around macro cell, so many femtocells will be there. So many smaller cells will be there. So this is the interference created to the first femtocell. This is the interference created to the second femtocell. Like that, I have taken V number of interferences. I have taken that V femtocells are there around the macro cell, around the major base station, so that V interferences are created. So here how many constraints are coming? How many constraints are coming? How many constraints are coming here? Yeah, this I1 is nothing but interference bearable by the first femtocell. I2 is nothing but interference bearable by the, interference tolerated by the second femtocell. Yeah, if I am creating more interference means even femtocells also will stop working. So I have to create interference. I have to create interference. Obviously it will be done, but that interference created to the xth femtocell should be smaller than the bearable interference only. Yeah, let us say that I can talk to you as long as you are traveling in the bus. Yeah, but for talking to you, after stepping down from the bus also, I can't barge into your home, right? Just like that. Even though I am not, okay, I have met some stranger in the bus. So with the stranger, I am talking. With the stranger, I am talking during my bus journey. But even after that stranger gets down from the bus and walked into his home, I can't just walk into his home to talk with him, right? I have to continue my travel. Same thing here. Yeah, that interference, the stranger can bear up to some amount. Whatever I have talked during the bus journey, yeah, obviously he has to hear. But even after stepping down from the bus also, I can't, what to say? I can't talk continuously with the stranger, right? Similarly to the interference also. Yeah, tolerable interference only I have to create for each and every femtocell. So here capital V amount of capital V femtocells are there. IV is the interference tolerable by the Vth femtocell. So this PM is nothing but powers allocated for my cell phone or something. Yeah, this is the maximization of capacity for the cell phone, and this is the interferences coming from the macro cell to the little cells, small cells or femtocells. So how to solve this problem? Any idea? How to calculate the powers easily here? How to calculate the powers easily? Remember I told you, as soon as I enter into the other network, I have to get video streaming. So that means for allocating the powers also it has to take very small time. So how to do this? Any idea?
NOMA, we are having the far users and near users taking, and we are using superposition coding theorem. We can allocate the powers for the near users and far users. I think it's based on the superposition coding. We can allot the powers from the near base stations to far base stations.
Yeah, it is your idea, but I have solved this problem in a different way. Yeah, C equal to, we have to maximize the capacity. C equal to sigma Bi log 2 1 plus Pi Hi by sigma square Yeah, sigma pi less than or equal to pt, sigma, okay, what is there? Yeah, TMV. TM1 pi less than or equal to I1, sigma TM2 P2 less than or equal to I2. Something like this is there. So how to solve these equations? I mean, how I have done is, I have taken maximize the capacity equal to sigma Bi log to 1 plus Pi Hi by sigma square in such a way sigma Pi less than or equal to Pt, Pi greater than or equal to 0. This one I have taken it as one water filling problem. This is the first equation, this is second equation, third equation. This I have taken it as water filling problem. For this water filling problem, let us say that I am allocating powers for, let us say some 1, 5, 6 channels. Let us say that by solving the first water filling problem, I am getting power allocation for first channel, fifth channel and sixth channel. Again, I have taken the maximize the capacity with respect to TM1 Pi less than or equal to I1, Pi greater than or equal to 0. This is second water filling problem. Second water filling problem, this is the second water filling problem. Again, after solving this water filling problem, let us say that one channel, let us say sixth channel, some ninth channel. These are getting power allocation. Like that I solve all the water filling problems. After solving all the water filling problems, how to solve for the final thing? How to get the final thing? For which channels I have to allocate the powers? Let us say that two constraints only are there. Third constraint is not there. Two constraints only are there. For the first constraint, I got the channels power allocation as first channel, fifth channel and sixth channel. By solving the second water filling problem, I got the channel allocation as first channel, sixth channel and ninth channel. I have done the power allocation. So, for which channels I have to do the power allocation if I am having 1 and 2 combinedly? Either you have to go for, so this is 156, this is 169. Either I have to go for union, or I have to go for intersection. Something I have to do with the existing channel. So instead of solving this, for solving this, it takes obviously so many constraints are there. It takes so much time for me to solve this. So instead of solving this, instead of taking long time to solve this, I am doing what, remember I have already solved water filling problem with a smaller number of iterations. So I will be taking very small time. I will be taking very small time here. If I take union or intersection, something like that. I have done so many combinations, union, intersection and okay. I have done it long back. I don't know how I have done also. I think I have taken union. This proposition 2. Okay. Any doubts here? I mean, again I have gone for some other methods also. I am not discussing all those methods. You understood whatever I have told you until now? Okay, next is NOMA. Yeah, this is the work done by one of my PhD student, Srinu Sunkraboina. He passed out here from here. So NOMA, non-orthogonal multiple axis. How many of you know about NOMA? How many of you know about NOMA? NOMA is 5G method. Yeah, you are NIT girls, no? Okay. Okay. What is the problem with OFDMA or orthogonal frequency division multiple axis? Yeah, orthogonal multiple axis. Second bullet. Orthogonal multiple axis means orthogonal frequency division multiple axis. Yeah, let me take it as, okay, 1 minute. What happened? Okay. Is it visible as it is? Yes, slideshow I tried to keep. Yeah, but I don't know why it is coming. Huh? Okay. OFDMA, what is done means we are having subcarriers. So this subcarrier, first subcarrier is allocated to first user, second subcarrier is allocated to some other user, third subcarrier is allocated to third user, fourth subcarrier is allocated to fourth user. Something like this is done in OFDMA or OMA. So here, but in NOMA what they do is, here they take same subcarrier is allocated to multiple number of users. Remember, in OFDMA, first subcarrier is allocated to first user, nth subcarrier is allocated to nth user. In that case, if you are allocating like this, what happens means you are not getting spectral efficiency. You are not getting spectral efficiency here. So let us say that F1 is allocated to the first user, F2 is allocated to the second user. F3 is allocated to the third user. In OFDMA, orthogonal frequency division multiple axis. What is the spectrum efficiency? Spectrum efficiency means, yeah, let us say that the same example of T you take. Yeah, you went to the cafeteria. You went to some cafeteria to have tea or coffee. Yeah, because it is owner's birthday. Owner has given you freely cake or something. In that case, you are getting maximum benefit out of that owner. You are paying only 5 rupees to the owner, but instead of getting 5 rupee result, you are getting 10 rupee or 15 rupees result. Same thing. Here, if we are allocating first channel to the first user, second channel to the second user, you are not getting efficiency, spectral efficiency. What is the meaning of spectral efficiency? How to the maximum extent we are able to utilize the spectrum. Remember, over the spectrum even ministers also have done so many scams. Why means even 1 hedge spectrum also gives 1 crore rupees or something cost. 1 hedge spectrum also. Huh? Entandi?
It is very costly.
Okay, thank you, ma. So that's why we want to utilize the spectrum to the maximum possible extent, because it is very costly affair. So what they try to do is, in a NOMA, they try to use the same spectrum. This is F1, yeah, user 1, user 2, yeah, some other spectrum is there, F2 spectrum, F2 spectrum, F2 spectrum. Here they are using, user 3 is using, user 4 is using, user 5 is using, same spectrum. Like that, same frequency channel is used by multiple users in NOMA. What is the advantage we get? What is the disadvantage we get? What is the advantage we get? What is the disadvantage we get? Okay. Yeah, okay. In OFDM, we are not able to utilize the spectrum efficiently, but whereas in NOMA, same spectrum we are utilizing for more number of users, so it increases the spectrum efficiency. So how they do is, yeah, please see this. Let us say that, yeah, this is F1 channel, this is F1 channel. So P1 power is allocated, P2 power is allocated. This is F2 channel, P3, P4, P5. So from the base station, same channel is utilized by, yeah, here UK minus 1, U2 signals. Yeah, that means that, yeah, here please see. Same channel is used by 2 users here. Same channel is used by other 2 users. Same channel is used by 2 users here. Why they are confining it to 2 users? Why not 3? Why not 4? Sridevi, don't respond. If we are using same channel by all the users, yeah, let us say we have allocated, P1 power is allocated over the F1 channel to the user 1, P2 power is allocated for the user 2 over the same channel. So what happens if you are doing it like this? Tell me, what happens to the interference? What happens to the interference? If I am using the same channel for m number of users, what happens to the interference? Interference will be more, right? Yeah, that's why they try to reduce the interference and they try to limit the number of users to 2, maximum 3 or 4. In all the literature work, they did not, no other has used more than 3 users. So here what they try to do is, once power allocation is done, yeah, let us say that what they try to do is, yeah, P1 X1, P2 X2, yeah, PM, XM is the signal that is transmitted. Here X1 is nothing but signal to be sent to first user. XM is nothing but mth user signal. How they do is, base station will be sending P1 X1, P2 X2 plus PM XM. Here P1 is the power allocated for sending the signal to the first user. P2 is the power allocated for sending the signal to the second user. PM is nothing but power allocated by the base station for sending mth signal to the mth user. Here X1 is the signal to be received by the first user. X2 is the signal to be received by the second user. XM is the signal to be received by the mth user. So combinedly at a stretch base station will be sending. So here each user what they try to do is they try to decode the other signals first. You know, everyone knows about successive interference cancellation, right? Yeah, sir told about V blast in the morning. What happens in the V blast? Successive interference cancellation. So first they try to decode. First, let us say that, yeah, it decodes X1 signal. Yeah, let us say that this is mth user. This is mth user. First it decodes X1 signal. After that, after decoding X1 signal, P1 X1, yeah, P2, I mean, H also will be there. H multiplying with P1 X1, P2 X2, PM XM. After decoding it, it tries to remove the X1 part. It tries to remove the X1 part. After removing X1, again, it tries to remove. Now remaining is HP2 X2, HP3 PM XM. This is the remaining part. So again it tries to remove second signal, HP2 X2, HP2 X2, H means channel. So after that, in that way, HPM XM will be there finally. HPM XM means, yeah, its own signal. Mth user signal that it has to receive mth signal. That's why it is done. Successive interference cancellation is done at every user here in the NOMA. Yeah, same signal is sent to M users or K users here. Yeah, first it is decoding UK and it is removing UK part, and again it is removing K minus 1th part. Like that it is removing second part. Finally it is getting, first user is getting first signal. Again here also it is removing other signals first. After removing other signals only it will get its own part, its own signal. Again it gets its own signal by removing all the other signals. Everyone understood that this is the NOMA. This is NOMA. So how to pair this? Here student have taken pairing methods. Let us say that 16 users are there. 16 users are there. How to pair the users? How to pair the users? Remember, student has taken only two users per a channel. 2 users per a channel. How to pair them? How to pair them? They have taken it like this. I mean 1, 3 odd number of channels they have taken, and again I think 10, 12, 14, 16. Some even number of channels they have taken. I mean, has checked so many variations. Yeah, finally it has given better result, I think. How to pair the users is the topic now. So here, if ith user and jth user is there, from the base station to the ith user, HSI is the channel gain. From the base station to the jth user, HSJ is the channel gain. So in that case, he has divided the power allocations into PI power allocation is done according to the channel gains. Alpha means, you know, right, path loss exponent. Path loss exponent depends on line of sight or number of obstructions. So here he has divided the powers into total power to be allocated over the channel, F1 channel or F2 channel, total power PS multiplying with, he has divided the power allocation as per the channel gains. HSI is the channel gain from base station to the ith user, HSJ is the channel gain from base station to the jth user. How much time is there? You want me to stop here or? Yeah, I thought you will say okay. 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 Here, so based on the channel gains, he has split the powers. So that means that PSI is the power allocated for the ith user, PSJ is the power allocated for the jth user. Here, tell me the equation for PSJ. Tell me the equation for PSJ, power allocated for the jth user. Power allocated for the jth user. Yeah, out of PS power, this sixth equation power is allocated to the ith user. Out of PS power, how much power we have to allocate to the jth user? That's what I am asking. Yeah, minus means what is that? Yeah, PS multiplying with HSJ whole square divided by total sum will be the power allocated for the jth user. According to the channel gains, the student has done the power allocation for a particular user. Yeah, how to pair the users? I will show the MATLAB code. Yeah, here. Total power they have taken it as, total power that is there for two users is 30 dBm. 30 dBm. So 30 dBm is converted into, yeah, linear scale in terms of watts or milliwatts. In terms of watts or milliwatts. So B is the bandwidth allocated for each channel. B is the bandwidth allocated for each channel. Yeah, if you don't understand, please ask. I am rushing through. Yeah, this is the noise power. This is the noise power. What is the noise power? What is the thermal noise power? KTB. Thermal noise power KTB. K Boltzmann constant. T is temperature or something. B is bandwidth. So that KT value is minus 174 in terms of dBm, I think. Yeah, this is a KTB. That KTB in terms of dBs. He has calculated. Yeah, same noise when converted into the linear values in terms of watts or milliwatts. Yeah, this is the noise power. This is the noise power. Again, eta equal to 4 is, yeah, Patra's exponent. Patra's exponent is taken. Here number of users, he is taking it as a 4:4:40 means, I don't know why he has taken it like this. I got the code yesterday only because I have to teach you today. Okay. Why? Yeah, okay, it is not going. So K equal to 4:4:40 means 4, 8, number of users, he has taken it as 40. Out of 40 users, he is splitting into 10 users group. First 10 users one group, second 10 users another group, third 10 users another group. Something like this is splitting, I think. Yeah, over 10 channels he has taken. Over 10 channels he is doing that NOMA. Here MC means maximum iterations he can have is taken as 3 into 10 to the power of 5. Once the number of iterations goes beyond 3 multiplying with 10 to the power of 5, he is stopping the work. So number of iterations, first iteration is starting here. First iteration is starting because it is for loop. Iteration equal to 1. In the one iteration, yeah, if it is running, it would have been better. Okay. Okay. First U equal to 1 is taken in the first iteration. S equal to KU by 2. S equal to KU by 2. That means that, maybe I am thinking, it is my thinking only. Yeah, he is splitting into top parts and bottom parts, I think. First one, red and green ones. By 2 he is doing means maybe he is splitting into user pairs. I don't know why he has taken again the noise here. Here, really I did not understand this. How he is calculating the channel gains here? Yeah, what I understood here is, after reading his code, yeah, this is some Gaussian he is creating. Gaussian, yeah, random means normal distribution. He is creating a normal distribution for n channels. Again, another Gaussian distribution for n channels, another Gaussian distribution for n channels, imaginary part. So this is nothing but a complex Gaussian distribution. So again, h should be equal to square root of capital H square, real part of H square plus imaginary part of H square. That's what we have to take to calculate the Rayleigh fading. To calculate the Rayleigh fading, we have to take root of real part of H square plus imaginary part of H square we have to take. Yeah, I did not understand this function. Similar, in the similar lines only he has taken. This is finally channel gains of Rayleigh fading for all n channels. For all n channels or n users, I think. N users or n channels? N users. N users it must be. So here these are G is nothing but Rayleigh fading channel gains for n users. Again, he is arranging the channels into descending order. Yeah, these channels are arranged into descending order because he has to pair now. Let's say that I have paired with 2 good channels. I have paired 2 users with the good channels. Let us say fighting is there. Fighting is, I mean, what is that? Wrestling is there. Wrestling competition is there. If both the wrestlers are, yeah, this much, what happens? If both the channels are this much, yeah, fat, what happens? First wrestler will fight with the second wrestler will get injuries, first wrestler also will get injuries. Yeah, I mean, yeah, that's okay. That's okay because both are strong, no problem at all. But if you are having wrestling competition between lean person and fat person, what happens? Yeah, lean person obviously will get more injuries, right? So how much power we have to allocate? I mean, before coming to the regular competition, what should the lean person do? Before coming to the wrestling competition, what should the lean person do? He has to use drugs or he has to eat some banana or something. He has to drink glucose or something before coming to the wrestling competition. So that's what here what we are doing is, for the weak channel, we are trying to allocate more powers. For the better channel, we try to allocate lesser powers. Something like that they are trying to do here. Yeah, that's why they are arranging the channel gains in descending order or increasing order. To choose the pairs, yeah, with equal fairness. Yeah, he is arranging the channels in descending order. He is arranging the channels in descending order. Yeah, this and all he has taken another methods for comparison. Whatever he has done, I will explain that only. Okay. Tell me, for I equal to 1, Yeah, let us say that for I equal to 1, for I equal to 1, for I equal to 1, channel gain as it is taken, channel gain as it is taken. For same channel gain, for the first user, if I equal to 1 is there means, I equal to 1 is there means, he is pairing with what is the ku bar minus s minus I, yeah, something. Yeah, he is pairing, pair 1, please see, user 1 is paired with user 10 here, user 1 is paired with user 10. Similarly, on the same lines, if he is taking ith user is paired with, yeah, k of u minus s plus I, this user. Ith user is paired with k of u minus s plus ith user. That's what is my understanding from his code. So after pairing them, I think he has checked so many combinations here, as per my understanding goes. Yeah, this is what he has done. Yeah, this one. Please try to understand. What is the meaning of this? For ith user, A to P is nothing but ith user power allocation. Ith user power allocation, what is the part of ith user power allocation? Yeah, please check channel gain whole over of alpha divided by, yeah, combination of channel gain whole over of alphas. Same thing he has taken here. Same thing he has taken here. How much part of a total power is to be allocated to the, yeah, some A to P user. Yeah, channel gain must be GSP has taken some variable. Channel gain whole to the power of minus alpha, channel gain whole to the power of minus alpha divided by combination of channel gain whole to the power of minus alphas. Yeah, this will be coming as, yeah, some 0.4 is coming here, some 0.4 is coming here. Out of total 1 watt, 0.4 watts is allocated for one user out of the user pair. Remaining thing, 1 minus 0.4, 1 minus 0.4, that means 0.6th part, 60% power is allocated for paired user. You are able to understand what I am saying, right? How much powers that guy is splitting the powers as per the channel gains. So out of PS equal to 1 watt, out of 1 watt, how much percentage is to be allocated with for the first user, how much percentage is to be allocated with paired user. That's what he is trying to calculate. So some 40% is allocated to the first user means to the paired user 60% will be allocated. Yeah, again he is calculating. After that PSK multiplying with, yeah, here. Yeah, try to understand, this is nothing but B is a bandwidth. B by S means maybe S number of users are there. S means 2 I think here. S means 2 users are paired. B by S means available bandwidth. Yeah, same bandwidth is allocated to both the users. So here PSK is the total power available 1 watt. Out of that, alpha part is to be allocated to the first user. GWP means, yeah, maybe channel gains. Channel gains. Yeah, please see. Yeah, why it is there here itself. Yeah, please see. Data rate available to the Sth user, data rate available to the kth user is nothing but B log 2 1 plus PKS. PKS is nothing but how much of power allocated to the user. HKS is the, yeah, power, channel gain for the kth user or something. This equation, same equation is solved by him to tell that this much capacity is available for the user after power splitting. You are able to understand what I am saying, right? If you are not getting anything, please ask. If 1 watt power is there, out of 1 watt, please check. Pair 1 is nothing but user 1 and user 10. User 1, for a user 1, if 60% power is allocated, for a user 10, for remaining 40% power is allocated. And power allocation depends on the channel gains as per his paper. After allocating the power, channel gains means it is based on distance only, na? I mean, his concept is different. According to his concept, I am explaining. So after allocating the powers, he is calculating the data rate available to the user 1, data rate available to the paired user. That equations are given. This is nothing but, these are nothing but splitting powers for the user pair. These are nothing but capacity coming for the ith user and other paired user. Everyone understood this, right? 517. Actually, I wanted to explain UAVs also. Can you listen? I wanted to explain about UAVs also. I will try to explain it in brief.
Tomorrow 12:30 to 1 you take. 12:30 to 1, SAR is closing early, so 12:30 to 1 you take tomorrow.
Okay. Okay.
Did you provide any PPTs for us, ma'am?
Huh?
Did you provide these?
These are available in net, na? You please download it because it will be benefit to me.
Now she is asking the code.
Code, no, code is not available. I will send the code, no problem, because it is already published, na? Okay, na? Then please carry on.
NOMA.
Spectral efficiency, sir. Because in orthogonal frequency division multiplexing, even though we are having orthogonal subcarriers, we are not able to utilize all those subcarriers fully. But in NOMA means, even though same carrier is there, that carrier will be utilized by more than 2 users. More than 2 users or at least 2 users. So spectral efficiency will be more. But the problem with NOMA is successive interference cancellation. Because successive interference cancellation is involved means, we can't have NOMA implementation for more than 3 users or 4 users for one frequency channel. Because it becomes a long time. He has explained it. Read this, sir. Large decoding delay means, if you are using the same channel for 100 users means, by the time each user gets the signal, 100th iterations are to be done. V blast receiver in the morning. Serious error propagation. If by any chance he is using one channel, base station is using one channel gain, to calculate this powers and all. By any chance base station did not predict the channel gain properly, or receiver did not predict the channel gain properly. So what happens if if the user did not predict the channel gain properly, because based on the channel gains only we are doing decoding, successive interference cancellation. If one signal goes wrong, Yeah, we are subtracting that decoded signal, na? The decoded signal itself goes wrong. Yes, again obviously second decoded signal also goes wrong, third decoded signal also goes wrong, 100th decoded signal also goes wrong. That is the problem with the successive interference cancellation. Everything goes wrong. If one thing is going wrong, everything goes wrong. Okay, na? Okay.